Can you solve all these thermodynamics questions? How many laws of thermodynamics are there? Option 1, a lot. Option 2, 3. Option 3, 4. Option 4, 1. 4, well done. What does the second law of thermodynamics consider that the zero and first cannot tell us? Option 1, adiabatic systems. Option 2, that work is not perpetual. Option 3, the quality of energy. Option 4, the third law. Outstanding effort, the quality of energy. Which law states that the entropy of a pure, perfect crystalline substance at 0K is 0? Option 1, first law of motion. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, first law of thermodynamics. Well expressed, third law of thermodynamics. A definite area or space where some thermodynamic process takes place is known as Option 1, system. Option 2, surroundings. Option 3, thermodynamics. Option 4, thermochemistry. Strong answer, system. The first law of thermodynamics is also called Option 1, law of energy. Option 2, law of enthalpy. Option 3, law of internal energy. Option 4, law of entropy. Commendable response. Law of internal energy. The pressures listed in thermodynamics tables are Option 1, gauge pressure. Option 2, atmospheric pressure. Option 3, absolute pressure. Option 4, vacuum pressure. Well articulated, absolute pressure. This states that energy is never created or destroyed. Heat lost by an object is gained by another. Option 1, Joule's law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, third law of thermodynamics. Precise answer, first law of thermodynamics. Which of the following concepts best describes a chlorophyll molecule absorbing light and changing it into chemical energy? Option 1, Bernoulli's principle. Option 2, Boyle's law. Option 3, the second law of thermodynamics. Option 4, the law of conservation of energy. Bravo! The law of conservation of energy! The first law of thermodynamics is concerned with conservation of Option 1, molecules. Option 2, moles. Option 3, energy. Option 4, temperature. Great job, energy! Mathematical expression of first law of thermodynamics is Option 1, dq equal to do plus vdp. Option 2, dia equal to dv pdj. Option 3, dia equal to do plus pj. Option 4, d's equal to dia plus pdj. Confident and correct. Dia equal to do plus pj. What is another name for the first law of thermodynamics? Option 1, law of energy destruction. Option 2, law of energy creation. Option 3, law of energy conservation. Option 4, law of energy dissipation. Keep it up, law of energy conservation. What is the law of thermodynamics that states that the change in internal energy, kinetic energy, and potential energy of a system is equal to the heat added to the system, minus the work done by the system? Option 1, second law. Option 2, first law. Option 3, zeroth law. Option 4, third law. Excellent reasoning. First law. Which law of thermodynamics is this? The entropy of a perfect crystal at absolute zero is 0. Option 1, zeroth law. Option 2, first law. Option 3, second law. Option 4, third law. Right choice, third law. The father of thermodynamics is dash. Option 1, Sadi Carnot. Option 2, Isaac Newton. Option 3, Albert Einstein. Option 4, Thomas Edison. Logical choice, Seti Carnot. Second law of thermodynamics. Option 1, every time energy changes form, some of it is lost to the environment. Option 2, energy can't be created or destroyed. Option 3, all energy generates heat. Option 4, none of above. Valid point. Every time energy changes form, some of it is lost to the environment. The entropy of the universe tends to be maximum. What of the laws of thermodynamics generalizes to the above statement? Option 1, 0th. Option 2, 1st. Option 3, 2nd. Option 4, 3rd. Excellent work. Second, this law states that the quantity of the substance entering the system is equal to the substance leaving the system. Option 1, first law of thermodynamics. Option 2, law of conservation of mass. Option 3, Newton's second law of motion. Option 4, law of conservation of energy. That's accurate. Law of conservation of mass. Everything outside a defined system is known as the dash. Option 1, surroundings. Option 2, open system. Option 3, closed system. Option 4, thermodynamics. Clear and correct. Surroundings. What is fusion? Option 1, the composition of molecules. Option 2, the decomposition of molecules. Option 3, the process between going from solid to liquid. Option 4, the process between going from liquid to gas. Good job. The process between going from solid to liquid? The first law of thermodynamics is a restatement of which law? Option 1, gravity. Option 2, Newton's first law. Option 3, conservation of energy. Option 4, Newton's second law. Perfect choice. Conservation of energy. First law of thermodynamics furnishes the relationship between Option 1, heat and work. Option 2, heat, work and properties of the system. Option 3, heat and internal energy. Option 4, various properties of the system. Nicely done. Heat, work and properties of the system. When two gases combine to form a new gas, as seen below, entropy decreases due to the smaller number of gas molecules in the product. Which law of thermodynamics? Option 1, 0th law. Option 2, first law. Option 3, second law. Option 4, third law. Accurate answer, second law. What is the main concept of the 0th law of thermodynamics? Option 1, thermal equilibrium. Option 2, entropy. Option 3, temperature measurement. Option 4, energy conservation. Thermal equilibrium is correct. The study of heat change in chemical reactions, such as during the formation of carbon sulfide from carbon and sulfur. Option 1, thermodynamics. Option 2, thermochemistry. Option 3, electrochemistry. Option 4, chemical kinetics. Exactly, thermochemistry. The first law of thermodynamics indicates that Option 1, work is force exerted over a distance. Option 2, energy is neither created nor destroyed. Option 3, an increase in disorder is part of any spontaneous process. Option 4, work is a state function. Well done. Energy is neither created nor destroyed. Which law of thermodynamics establishes absolute zero as the temperature at which the entropy of a system is zero? Option 1, first law. Option 2, an if. Option 3, show if. Option 4, 0th law. On track, show if. According to the laws of thermodynamics, thermal energy always moves dash. Option 1, from the colder substance to the warmer substance. Option 2, from the warmer substance to the colder substance. Option 3, from the final to the initial temperature. Option 4, from the kinetic to the potential energy. Very good. From the warmer substance to the colder substance. Which law of thermodynamics is this? Energy can never be created or destroyed, but it can change forms. Option 1, zeroth law. Option 2, first law. Option 3, second law. Option 4, third law. Correct response, first law. A more elaborate approach, based on the average behavior of large groups of individual particles, is called Option 1, classical thermodynamics. Option 2, statistical thermodynamics. Option 3, microscopic approach. Option 4, none of the above. You got it! Statistical thermodynamics! Which of the following is equivalent to the principle of energy conservation? Option 1, Newton's first law. Option 2, the first law of thermodynamics. Option 3, Newton's second law. Option 4, the second law of thermodynamics. Right, the first law of thermodynamics. What is the first law of thermodynamics? Option 1, energy cannot be created or destroyed. It can only change forms. Option 2, energy can be created, but it cannot be destroyed. Option 3, energy cannot be created, but it can be destroyed. Option 4, energy can be created, destroyed, or change forms. Spot on. Energy cannot be created or destroyed. It can only change forms. The second law of thermodynamics states dash. Option 1, entropy always increases for a closed system. Option 2, energy is constant in the universe. Option 3, all reactions are reversible. Option 4, none of above. Solid response. Entropy always increases for a closed system. The second law of thermodynamics states that thermal energy can flow from colder objects to hotter objects. Option 1, by convection. Option 2, only if work is done on the system. Option 3, spontaneously. Option 4, when therm expansion takes place. Thoughtful answer. Only if work is done on the system. An old car with a lot of mileage is more likely to break down than a new car that has not been driven a lot. This is an example of dash. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, none of above. Nice work, second law of thermodynamics. As time progresses, energy will naturally become more spread out. It can only come together if you make it. Option 1, zeroth law of thermodynamics. Option 2, third law of thermodynamics. Option 3, first law of thermodynamics. Option 4, second law of thermodynamics. Well supported, second law of thermodynamics. Which of the following states that absolute zero cannot be reached? Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, second and third laws of thermodynamics. Well reasoned. Third law of thermodynamics. Entropy is the amount of disorder in a system. The third law of thermodynamics explains the conditions for attaining minimum entropy. Which fundamental process will get a system to this state? Option 1, cooling to absolute zero temperature. Option 2, heating to absolute zero temperature. Option 3, adding more energy to the system. Option 4, none of above. That's it. Cooling to absolute zero temperature. What do we call the relationship between thermal energy, heat, and work? Option 1, closed system. Option 2, entropy. Option 3, conductors. Option 4, thermodynamics. Thermodynamics. Great work. Thermodynamics is a science that deals with heat and work and those dash of substance that bear a relation to heat and work. Option 1, energies. Option 2, states. Option 3, properties. Option 4, processes. Yes, properties is right. When two bodies are in thermodynamic equilibrium with a third body, they are also in thermodynamic equilibrium with each other. This statement is called the dash. Option 1, 0th law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, third law of thermodynamics. Smart thinking. 0th law of thermodynamics. Thermodynamics is based on study of dash of the system. Option 1, microscopic properties. Option 2, macroscopic properties. Option 3, physical properties. Option 4, chemical properties. Confident and correct. Macroscopic properties. The study of energy transformations involving heat, mechanical work, and other aspects of energy and how these transformations relate to the properties of matter. Option 1, electromagnetism. Option 2, thermodynamics. Option 3, optics. Option 4, electrodynamics. Correct response, thermodynamics. Whenever heat is added to a system, it transforms to an equal amount of some other form of energy describes which law of thermodynamics. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, fourth law of thermodynamics. Accurate answer, first law of thermodynamics. Which of the following is the basis of temperature measurement? Option 1, 0th law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, third law of thermodynamics. Well reasoned. 0th law of thermodynamics. The measurement of a thermodynamics property known as temperature is based on Option 1, 0th law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, none of above. Keep it up, 0th law of thermodynamics. The lowest temperature that is theoretically possible, at which the motion of particles would be minimal. Option 1, specific heat. Option 2, latent heat. Option 3, thermodynamics. Option 4, absolute zero. Thoughtful answer, absolute zero. The law stating the heat energy always goes towards entropy, or moves from hot to cold and from order to disorder, is known as dash. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, Newton's first law. Option 4, Newton's second law. Well supported, second law of thermodynamics. Zoe is observing a closed container with a mixture of ice and water inside. According to the first law of thermodynamics, what happens to the total energy of the system when the ice melts and the water reaches room temperature? Option 1, the total energy of the system becomes negative. Option 2, the total energy of the system increases. Option 3, the total energy of the system remains constant. Option 4, the total energy of the system decreases. Bravo! The total energy of the system remains constant. The transfer of internal energy. Option 1, temperature. Option 2, kinetic energy. Option 3, thermodynamics. Option 4, heat. Well done, heat! A concept that addresses entropy. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, zeroth law. Great job! Second law of thermodynamics? Relations between heat and other forms of energy. Option 1, activation energy. Option 2, phase change. Option 3, conduction. Option 4, thermodynamics. Yes, thermodynamics is right. A condition in which all parts of a system are at the same temperature. Option 1, thermodynamics. Option 2, temperature. Option 3, thermal equilibrium. Option 4, thermal expansion. Strong answer. Thermal equilibrium. Second law of thermodynamics. Option 1 removes all limitation of first law of thermodynamics. Option 2 removes numerical value of first law of thermodynamics. Option 3, opposite rule of energy conservation rule. Option 4, none of these. Exactly. Removes all limitation of first law of thermodynamics. The entropy of a perfectly crystalline substance at absolute zero is zero. The state corresponds to which law of thermodynamics? Option 1, zeroth law. Option 2, second law. Option 3, third law. Option 4, first as well as second. Spot on! Third law! The term thermodynamics was first used in 1849 in the publication of a Option 1, Rudolf Clausius. Option 2, William Rankine. Option 3, Lord Kelvin. Option 4, Thomas Savery. Very good, Lord Kelvin. What does the second law of thermodynamics state about the total entropy of a system? Option 1, the total entropy of a system will decrease over time. Option 2, the total entropy of a system will always increase over time. Option 3, the total entropy of a system remains constant over time. Option 4, the total entropy of a system is not related to time. Nice work. The total entropy of a system will always increase over time. What is the concept of energy being neither created nor destroyed, only transferred or transformed? Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, entropy. Option 4, Gibbs, free energy. Excellent reasoning. First law of thermodynamics. In this case, we can see what thermodynamics law. Option 1, first law. Option 2, show no. Option 3, zero law. Option 4, and if. And if, well done. What occurs when Q equal to 0, so that the first law of thermodynamics takes the form of U equal to W? Option 1, an isovolumetric process. Option 2, an isothermal process. Option 3, an adiabatic process. Option 4, an isolated system. Nicely done. An adiabatic process. System, boundary, and surrounding can be explained that related to. Option 1, energy conservation. Option 2, concept of thermodynamics. Option 3, the principles of thermodynamics. Option 4, process of thermodynamics. Perfect choice. The principles of thermodynamics. Zeroth law of thermodynamics is related to. Option 1, chemical equilibrium. Option 2, mechanical equilibrium. Option 3, thermal equilibrium. Option 4, chemical equilibrium. Right choice. Thermal equilibrium. If object A and B have the same temperature and object C is the same temperature as object of all three are the same temperature. This tendency illustrates which of the following laws of thermodynamics Option 1, zeroth law. Option 2, first law. Option 3, second law. Option 4, third law. Good job, zeroth law. Which law of thermodynamics states that energy cannot be created or destroyed? Option 1, first law. Option 2, second law. Option 3, third law. Option 4, zeroth law. Right, first law. In thermodynamics, a process is called reversible when Option 1, surroundings and system change into each other. Option 2, there is no boundary between system and surroundings. Option 3, the surroundings are always in equilibrium with the system. Option 4, the system changes into the surroundings spontaneously. On track. The surroundings are always in equilibrium with the system. Heat will never flow from a cold object to a hot object on its own describes which law of thermodynamics? Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, fourth law of thermodynamics. Logical choice. Second law of thermodynamics. What is thermodynamics primarily concerned with? Option 1, the study of weather patterns and climate change. Option 2, the study of energy and energy transformations. Option 3, the study of atmospheric pressure and wind systems. Option 4, none of above. Smart thinking. The study of energy and energy transformations. Thermodynamics is the study of Option 1, energy. Option 2, equilibrium. Option 3, energy transformation. Option 4, all. Well expressed, all. The zeroth law of thermodynamics states, Option 1, you cannot convert 100% of heat into work. Option 2, absolute zero cannot be attained. Option 3, two objects touching will reach a temperature equilibrium. Option 4, internal energy equals work plus heat. You got it! Two objects touching will reach a temperature equilibrium. When a substance or material gets hotter, it expands to a greater volume. This is called dash. Option 1, thermodynamics. Option 2, temperature. Option 3, thermal equilibrium. Option 4, thermal expansion. Precise answer, thermal expansion. Which of the following statements is in agreement with the second law of thermodynamics? Option 1, it is possible to continuously convert thermal energy fully into work. Option 2, in natural processes, local entropy must increase. Option 3, thermal energy will not flow by itself from cold to hot bodies. Option 4, the entropy in a closed system tends to decrease. Clear and correct. Thermal energy will not flow by itself from cold to hot bodies. Why will a glass of water in a room never become lower than the temperature of the room? Option 1, it would violate the law of entropy. Option 2, it would violate the first law of enthalpy. Option 3, it would violate the third law of thermodynamics. Option 4, none of the above are correct. This could happen. Outstanding effort. It would violate the law of entropy. Thermodynamics is the study of what? Option 1, the transfer of energy. Option 2, the creation of energy. Option 3, the speed of reactions. Option 4, the effect of heat on the speed of a reaction. Well articulated. The transfer of energy. Thermodynamics process in which no heat loss, no heat gain, that is completely insulated system. Option 1, adiabatic process. Option 2, quasi-static process. Option 3, irreversible process. Option 4, reversible process. Commendable response. Adiabatic process. A diagram that displays the potential energy of a system on the y-axis and the reaction progress on the x-axis. Option 1, potential energy diagram. Option 2, second law of thermodynamics. Option 3, surroundings. Option 4, thermodynamics. Potential energy diagram. Great work. According to the first law of thermodynamics, energy is created by dash. Option 1, running. Option 2, boiling ice. Option 3, touching slime. Option 4, none of these. Solid response. None of these. The third law of thermodynamics. Option 1. The energy of the universe is constant, and energy cannot be created nor destroyed. Option 2, entropy increases naturally in the universe. Option 3, at 0 Kelvin. Entropy of all chemicals is 0. Option 4, none of above. Excellent work. At T0 Kelvin, entropy of all chemicals is 0. The heat content of a reaction is called Option 1, enthalpy. Option 2, entropy. Option 3, specific heat. Option 4, thermodynamics. Valid point. Enthalpy. What is the reason why even the coldest places on Earth aren't at absolute zero, according to the third law of thermodynamics? Option 1. The entropy of the system approaches 0. Option 2. The temperature of Earth is constantly increasing. Option 3. The movement of particles in a substance stops completely. Option 4. It is impossible to reach absolute 0. That's accurate. It is impossible to reach absolute 0. This states that it is impossible to achieve a temperature of absolute 0. Option 1, 0th law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, third law of thermodynamics. That's it. Third law of thermodynamics. Which of the following law of thermodynamics was expressed by Nernst? Option 1, the first law of thermodynamics. Option 2, the second law of thermodynamics. Option 3, the third law of thermodynamics. Option 4, the 0th law of thermodynamics. The third law of thermodynamics is correct. Which scientific principle states that energy spontaneously spreads from more concentrated regions to less concentrated regions? Option 1, second law of thermodynamics. Option 2, first law of thermodynamics. Option 3, law of conservation of energy. Option 4, law of heat and work. Perfect choice. Second law of thermodynamics. The study of energy and its transformations. Option 1, thermodynamics. Option 2, entropy. Option 3, physics. Option 4, chemistry. Correct response, thermodynamics. Thermodynamics is a branch of physical sciences that treats of various phenomena of dash and the related properties of matter, especially the laws of transformation of heat into other forms of energy and vice versa. Option 1, state. Option 2, heat. Option 3, work. Option 4, energy. Energy, well done. The first law of thermodynamics tells us that heat and dash are related. Option 1, force. Option 2, entropy. Option 3, inertia. Option 4, energy. That's accurate. Energy. First law of thermodynamics is the conservation of Option 1, radiation energy. Option 2, heat energy. Option 3, electric energy. Option 4, magnetic energy. Heat energy is correct. Which law of thermodynamics says that the efficiency of a heat engine cannot be 1? Option 1, first. Option 2, 0th. Option 3, second. Option 4, third. Accurate answer, second. The sun provides most of the energy the Earth needs to support the living. This is an example of dash. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, none of above. Nice work, first law of thermodynamics. A heat engine absorbs heat Q1 at temperature T1 and heat Q2 at temperature T2. Work done by the engine is this data. Option 1 violates first law of thermodynamics. Option 2 violates first law of thermodynamics if Q1 is V. Option 3 violates first law of thermodynamics if Q2 is V. Option 4 does not violate first law of thermodynamics. That's it. Does not violate first law of thermodynamics. What does the second law of thermodynamics state? Option 1, that entropy always increases. Option 2, that entropy decreases. Option 3, that entropy is heat. Option 4, that entropy is order. That entropy always increases. Great work. According to first law of thermodynamics, Option 1, total internal energy of a system during a process remains constant. Option 2, total energy of a system remains constant. Option 3, work done by a system is equal to the heat transferred by the system. Option 4, internal energy, enthalpy and entropy during a process remains constant. Excellent work. Total internal energy of a system during a process remains constant. Which of the laws of thermodynamics addresses thermal equilibrium? Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, fourth law of thermodynamics. Well supported. Fourth law of thermodynamics. The fact that energy can be neither created nor destroyed is dash. Option 1, not true. Option 2, Newton's first law of motion. Option 3, the first law of thermodynamics. Option 4, Einstein's law. Great job! The first law of thermodynamics! The first law of thermodynamics is also the law of dash. Option 1, conservation of mass. Option 2, conservation of energy. Option 3, conservation of light. Option 4, conservation of natural resources. Well expressed. Conservation of energy. Dash is the study of the flow and transformation of energy. Option 1, chemistry. Option 2, energy. Option 3, entropy. Option 4, thermodynamics. Right? Thermodynamics. What did the paper published by Carnot in 1824 contain, although not in the same terms we'd use today? Option 1, the second law of thermodynamics. Option 2, the science of absolute temperatures. Option 3, the first law of thermodynamics. Option 4, the Carnot cycle. Very good. The second law of thermodynamics. A law that if two systems are separately found to be in thermal equilibrium with a third system, the first two systems are in thermal equilibrium with each other. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, zeroth law of thermodynamics. Option 4, none of above. Exactly. Zeroth law of thermodynamics states that the change in thermal energy of a system is equal to the heat that is added to the system minus the work done by the system. Option 1, second law of thermodynamics. Option 2, first law of thermodynamics. Option 3, thermal equilibrium. Option 4, heat of vaporization. Yes, first law of thermodynamics is right. The concept that matter transitions from order to chaos is Option 1, entropy. Option 2, thermodynamics. Option 3, energy transfer. Option 4, energy transformation. On track, entropy. Thermodynamics give chemists an idea of which direction the minimum dash of a given reaction lies. Option 1, reaction time. Option 2, reaction volume. Option 3, potential energy. Option 4, none of these. Well done, potential energy! What is the significance of entropy, according to the third law of thermodynamics? Option 1, entropy of a system decreases as its temperature approaches absolute zero. Option 2, entropy of a system increases as its temperature approaches absolute zero. Option 3, entropy of a system approaches a constant value as its temperature approaches absolute zero. Option 4, none of above. You got it. Entropy of a system approaches a constant value as its temperature approaches absolute zero. PM1 is a violation of Option 1, 0th law of thermodynamics. Option 2, the first law of thermodynamics. Option 3, the second law of thermodynamics. Option 4, Clausius theorem. Keep it up, the first law of thermodynamics. According to second law of thermodynamics, heat can be converted into mechanical work if the system contains Option 1, 2 heat reservoirs at different temperatures. Option 2, engine and heat reservoir at zero temperature. Option 3, engine and heat reservoir at the same temperature. Option 4, engine and 2 heat reservoirs at different temperatures. Spot on. Engine and 2 heat reservoirs at different temperatures? Branch of physics that deals with the relationships between heat and other forms of energy. Option 1, thermodynamics. Option 2, thermal expansion. Option 3, conservation of energy. Option 4, conversion rates. Right choice, thermodynamics. One consequence of the third law of thermodynamics is that Option 1, heat engines have efficiencies less than 100%. Option 2, in some energy conversions, energy is not conserved. Option 3, engines cannot discharge waste heat. Option 4, the work a heat engine produces is less than the waste heat it produces. Outstanding effort. Heat engines have efficiencies less than 100%. A heat engine absorbs heat Q1 at temperature T1 and heat Q2 at temperature T2. The work done by the engine is J. This data. Option 1 violates first law of thermodynamics. Option 2 violates first law of thermodynamics if Q1 is V. Option 3 violates first law of thermodynamics if Q2 is V. Option 4 does not violate the first law of thermodynamics. Smart thinking does not violate the first law of thermodynamics. The first law of thermodynamics deals with Option 1, conservation of mass. Option 2, conservation of enthalpy. Option 3, conservation of energy. Option 4, conservation of momentum. Solid response. Conservation of energy. The second law of thermodynamics can be described as Option 1, the law of entropy. Option 2, the particle model. Option 3, the law of conservation. Option 4, the reason we love science. Valid point, the law of entropy. The study of thermodynamics that does not require a knowledge of the behavior of individual particles. Option 1, general thermodynamics. Option 2, microscopic approach. Option 3, statistical thermodynamics. Option 4, classical thermodynamics. Excellent reasoning, classical thermodynamics. The first law of thermodynamics states that the change in the internal energy of a system is equal to the difference in energy transferred to or from the system as heat. And option 1 pressure, option 2 work done, option 3 force, option 4 mass. Good job, work done! The first law of thermodynamics is also known as the law of dash of energy. Option 1 creation, option 2 destruction, option 3 conservation, option 4 ever-changing. Well-reasoned, conservation. Thermodynamics is the study of how dash. Option 1 heat is form of energy. Option 2 heat can be converted into other form of energy. Option 3 to do work. Option 4 to decrease consumption of heat. Strong answer. Heat can be converted into other form of energy. This diagram represents dash law of thermodynamics. Option 1 first. Option 2 second. Option 3 zeroth. Option 4 third. Commendable response, zeroth. According to the first law of thermodynamics, what can happen to energy? Option 1 energy can be created from nothing. Option 2 energy can be destroyed completely. Option 3 energy can be converted from one form to another. Option 4 energy can disappear without a trace. Nicely done. Energy can be converted from one form to another. Dash is defined as disorder, randomness, or unstableness. Option 1 thermodynamics. Option 2 entropy. Option 3 the Big Bang. Option 4 none of the options. Logical choice, entropy. What is the definition of thermodynamics? Option 1 the energy available to do work. Option 2 the study of the relationship between heat, work, and energy. Option 3 the amount of heat it takes to move an engine. Option 4 the movement of heat. Thoughtful answer. The study of the relationship between heat, work, and energy. The first law of thermodynamics states, Option 1 energy can be created, destroyed, and transferred. Option 2 energy cannot be created, destroyed, but can be transferred. Option 3 energy cannot be transferred. Option 4 energy doesn't exist. Well articulated, energy cannot be created, destroyed, but can be transferred. The second law of thermodynamics is also called the law of dash. Option 1 energy. Option 2 entropy. Option 3 heat. Option 4 phase change. Clear and correct, entropy. Which law of thermodynamics best explains why ice melts and tea cools to the same temperature when the ice is placed in a cup of hot tea? Option 1 zeroth law. Option 2 first law. Option 3 an if. Option 4 show if. Bravo, yoth law! According to the second law of thermodynamics, in an isolated system, entropy. Option 1 remains constant. Option 2 decreases over time. Option 3 increases over time. Option 4 is not affected by time. Precise answer, increases over time. The first law of thermodynamics applies the conservation of energy principle to systems where heat transfer and doing work are the methods of dash. Option 1, isolating heat. Option 2, creating energy. Option 3, reacting to force. Option 4, transferring energy. Confident and correct, transferring energy. The stored energy in food is converted to chemical energy when you eat is an example of the dash law of thermodynamics. Option 1 first. Option 2 and. Option 3 an offer. Option 4 sh. Nicely done. First. The first law of thermodynamics is a restatement of what? Option 1, the second law of thermodynamics. Option 2, the law of conservation of energy. Option 3, the first law of motion. Option 4, the first law of thermodynamics. Great job! The law of conservation of energy! What are the different types of work in thermodynamics? Option 1, volume work, gravitational work, and kinetic work. Option 2, shaft work, electrical work, and flow work. Option 3, chemical work, nuclear work, and radiation work. Option 4, heat work, magnetic work, and pressure work. Exactly. Shaft work, electrical work, and flow work. Dash means that energy cannot be destroyed. Option 1, first law of thermodynamics. Option 2, entropy. Option 3, conservation of energy. Option 4, none of above. Perfect choice. Conservation of energy. A measure of the amount of disorder or randomness in a system. Option 1, entropy. Option 2, exothermic. Option 3, first law of thermodynamics. Option 4, heat engine. Commendable response. Entropy? What is the zeroth law of thermodynamics about? Option 1, thermal radiation between bodies. Option 2, thermal expansion of bodies. Option 3, thermal insulation of bodies. Option 4, thermal equilibrium between bodies. Precise answer. Thermal equilibrium between bodies. Zeroth law of thermodynamics defines dash. Option 1, energy equilibrium is transitive. Option 2, it is about how to quantify the temperature. Option 3, work equilibrium is transitive. Option 4, pure substance. Accurate answer. It is about how to quantify the temperature. Dash explains why heat always flows from an object with a higher temperature to an object of lower temperature naturally. Option 1, thermal expansion. Option 2, caloric theory. Option 3, second law of thermodynamics. Option 4, convection transfer. Well expressed. Second law of thermodynamics. The second law of thermodynamics states that thermal energy always moves. Option 1, from a high temperature object to a lower temperature object. Option 2, from a lower temperature object to a higher temperature object. Option 3, from an object with lower kinetic energy to an object with higher kinetic energy. Option 4, from an object of higher mass to an object of lower mass. From a high temperature object to a lower temperature object is correct. It states that if two thermodynamic systems are each in thermal equilibrium with a third, then they are in thermal equilibrium with each other. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, zeroth law. Logical choice, zeroth law. Thermodynamics is not concerned about. Option 1, energy change involved in a chemical reaction. Option 2, the extent to which a chemical reaction proceeds. Option 3, the rate at which a reaction proceeds. Option 4, the feasibility of a chemical reaction. Correct response, the rate at which a reaction proceeds. Both the calorie and the joule are units of energy in thermodynamics. Which of the following statements is true? Option 1, 1 joule equal to 0.239 calories. Option 2, 1 calorie equal to 0.001 joules. Option 3, 1 joule equal to 4.19 calories. Option 4, 1 calorie equal to 1,000 joules. Excellent work. 1 joule equal to 0.239 calories. Another name for the first law of thermodynamics is Option 1, the law of entropy. Option 2, the law of conservation of energy. Option 3, the law of conservation of mass. Option 4, the law of gravitation. Excellent reasoning. The law of conservation of energy. Any process that increases the volume of a given mass of gas is called dash. Option 1, specific heat. Option 2, compression. Option 3, thermodynamics. Option 4, expansion. Spot on. Expansion! What does the 0th law of thermodynamics help define? Option 1, pressure. Option 2, density. Option 3, temperature. Option 4, volume. Temperature. Great work. What happens to the heat energy from a hot cup of coffee when left in a room according to the 2nd law of thermodynamics? Option 1, it decreases. Option 2, it is absorbed by the room. Option 3, it remains constant. Option 4, it spreads out into the room. Good job, it spreads out into the room. The 2nd law of thermodynamics defines Option 1, heat. Option 2, work. Option 3, internal energy. Option 4, entropy. That's accurate. Entropy. Which law of thermodynamics states that absolute zero cannot be reached? Option 1, first. Option 2, second. Option 3, third. Option 4, 0th. Valid point, third. In thermodynamics, which is not a state variable. Option 1, density. Option 2, internal energy. Option 3, enthalpy. Option 4, heat. Heat, well done. The change in energy of a system equals the heat added to it plus the work done on it. Option 1, first law of thermodynamics. Option 2, 2nd law of thermodynamics. Option 3, 3rd law of thermodynamics. Option 4, 0th law. You got it! First law of thermodynamics. What is the main concept of the first law of thermodynamics regarding energy? Option 1, energy is created. Option 2, energy is destroyed. Option 3, energy is transformed. Option 4, energy is conserved. Confident and correct. Energy is conserved. The 2nd law of thermodynamics says that heat always flows from an object with a higher temperature dash. Option 1, to infinity and beyond. Option 2, to free space. Option 3, to an object with lower temperature. Option 4, to an object with lower specific heat. Clear and correct. To an object with lower temperature. Which scientist is not known for contributions to the development of the laws of thermodynamics? Option 1, Newton. Option 2, Carnot. Option 3, Leibniz. Option 4, Boltzmann. Well done, Newton! In thermodynamics, which one of the following is not an intensive property? Option 1, pressure. Option 2, density. Option 3, volume. Option 4, temperature. That's it, volume. The law formulated by Dirch or Nernst is Option 1, first law of thermodynamics. Option 2, 2nd law of thermodynamics. Option 3, 3rd law of thermodynamics. Option 4D, both and. Bravo! 3rd law of thermodynamics! Thermodynamics is the study of 3 E's. Option 1, energy, equilibrium, engine. Option 2, energy, equality, engine. Option 3, energy, equilibrium, entropy. Option 4, enthalpy, equilibrium, engine. Thoughtful answer, energy, equilibrium, entropy. Energy can be converted from one form to another with the interaction of heat, work, and internal energy, but it cannot be created nor destroyed under any circumstances. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, zeroth law of thermodynamics. Keep it up, first law of thermodynamics. Entropy is closely related to the Option 1, second law of thermodynamics. Option 2, first law of thermodynamics. Option 3, both of the above. Option 4, none of the above. Very good. Second law of thermodynamics. Second law of thermodynamics. Option 1, the energy of the universe is constant and energy cannot be created nor destroyed. Option 2, the entropy of the universe naturally increases. Option 3, entropy of chemicals is zero at absolute zero. Option 4, none of above. Well supported. The entropy of the universe naturally increases. The second law of thermodynamics is known as the law of entropy and focuses on Option 1, thermal equilibrium. Option 2, heat transfer. Option 3, thermal expansion. Option 4, conduction and insulation. On track, heat transfer. The dash law of thermodynamics says that heat always flows from an object with a higher temperature to an object of lower temperature naturally. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, zeroth law. Outstanding effort. Second law of thermodynamics. The first law of thermodynamics indicates that Option 1, work is force exerted over a distance. Option 2, energy in the universe is finite. Option 3, an increase in disorder is part of any spontaneous process. Option 4, work is a state function. Solid response. Energy in the universe is finite. According to the second law of thermodynamics, how is heat naturally transferred? Option 1, from a system with lower entropy to a system with higher entropy. Option 2, from a colder body to a hotter body. Option 3, from a hotter body to a colder body, but not in the reverse direction. Option 4, none of above. Smart thinking. From a hotter body to a colder body, but not in the reverse direction. The second law of thermodynamics states that entropy of a system tends to dash. Option 1, increase. Option 2, decrease. Option 3, stay constant. Option 4, fluctuate wildly. Nice work, increase. What does the second law of thermodynamics state about entropy? Option 1, it remains constant. Option 2, it decreases over time. Option 3, it fluctuates randomly. Option 4, it increases over time. Right, it increases over time. The dash law of thermodynamics states that the change in energy is the sum of the heat added and the work done. Option 1, zeroth. Option 2, first. Option 3, and. Option 4, and offer. Well reasoned, first. When changes in energy are studied from chemistry point of view. Option 1, thermodynamics. Option 2, chemical thermodynamics. Option 3, chemical reaction. Option 4, heat transfer. Right choice. Chemical thermodynamics. Thermodynamics is the study of dash. Option 1, movement and vectors. Option 2, atoms and magnetism. Option 3, temperature, heat and energy. Option 4, none of above. Yes, temperature, heat and energy is right. What is a system in thermodynamics? Option 1, everything outside a system. Option 2, a region of the universe that we direct our attention to. Option 3, the boundary or wall that separates a system from its surroundings. Option 4, none of the above. Strong answer. A region of the universe that we direct our attention to. Carnot cycle is the application of Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, none of these. Well articulated. Second law of thermodynamics. Gas molecules move around randomly, and the volume of the gas molecules is negligible. R dash. Option 1, assumptions of the ideal gas law. Option 2, true statements that apply to all gases no matter what. Option 3, invalid statements. Option 4, the second law of thermodynamics. Right choice. Assumptions of the ideal gas law. All thermodynamics can be expressed in terms of 4 quantities, except Option 1, temperature. Option 2, internal energy. Option 3, entropy. Option 4, luminous intensity. Outstanding effort. Luminous intensity. What does thermodynamics explain? Option 1, the origin of the universe. Option 2, the composition of chemical elements. Option 3, how energy is transferred between different forms. Option 4, the structure of atomic particles. On track. How energy is transferred between different forms. First law of thermodynamics, also known as Option 1, law of conservation of energy. Option 2, law of conservation of entropy. Option 3, law of conservation of studies. Option 4, all of the above. That's it. Law of conservation of energy. The first law of thermodynamics states that the heat transferred to or from the system is equal to the change in the internal energy of a system plus dash. Option 1, work done on the system. Option 2, work done by the system. Option 3, work done by the external forces. Option 4, negative work done by the system. Work done by the system is correct. Some surgeries are performed with a patient packed in ice to slow down their metabolic rate. This is an example of dash. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, none of above. Well articulated, third law of thermodynamics. Heat spontaneously flowing from a cold body to a hot body violates the dash. Option 1, law of conservation of energy. Option 2, kinetic molecular law. Option 3, first law of thermodynamics. Option 4, second law of thermodynamics. Well done, second law of thermodynamics! It states that if two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, third law of thermodynamics. Option 4, zeroth law of thermodynamics. Precise answer, zeroth law of thermodynamics. A system in which both energy and matter can enter or exit. Option 1, open system. Option 2, potential energy diagram. Option 3, second law of thermodynamics. Option 4, surroundings. Logical choice, open system. What process occurs when Q equal to W equal to 0, so that the first law of thermodynamics takes the form of U equal to 0? Option 1, an isovolumetric process. Option 2, an isothermal process. Option 3, an adiabatic process. Option 4, an isolated system. Correct response, an isothermal process. If it has the same temperature as B and C are in thermal equilibrium. Which law does this refer to? Option 1, zeroth law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, third law of thermodynamics. Great job! Zeroth law of thermodynamics! The following question has 4 choices, out of which only one is correct. Which of the following is incorrect regarding the first law of thermodynamics? A. It is not applicable to any cyclic process. B. It is a restatement of the principle of conservation of energy. C. It introduces the concept of the internal energy. D. It introduces the concept of the entropy. Option 1, A and D. Option 2, B and C. Option 3, C and I. Option 4, A and B. Well reasoned. A and D. The first law of thermodynamics. Option 1, the energy of the universe is constant. Option 2, the universe is constantly increasing the dispersal of matter and energy. Option 3, the entropy of a perfect crystal at T0K is 0. Option 4, none of above. Yes, the energy of the universe is constant is right. This states that heat will always flow from hot objects to cold objects, efficiency is always less than 100%, and total disorder can never increase. Option 1, zoeth law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, third law of thermodynamics. Second law of thermodynamics. Great work. It states that energy can neither be created nor destroyed, but only converted from one form to another. Option 1, first law of thermodynamics. Option 2, Newton's first law. Option 3, second law of thermodynamics. Option 4, Newton's second law. Exactly. First law of thermodynamics. What is thermodynamics? Option 1, movement of heat. Option 2, it's magic. Option 3, measurement of heat. Option 4, none of them. Commendable response. Movement of heat. When two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. This statement is called Option 1, zeroth law of thermodynamics. Option 2, first law of thermodynamics. Option 3, second law of thermodynamics. Option 4, Kelvin Planck's law. Right, zeroth law of thermodynamics. What does the entropy of a perfect crystal at absolute zero temperature tend to be according to the third law of thermodynamics? Option 1, 0. Option 2, infinite. Option 3, constant. Option 4, unpredictable. You got it, 0! What does the first law of thermodynamics state? Option 1, that energy cannot be created or destroyed, only transformed. Option 2, that energy is a form of work. Option 3, that energy is able to be created and destroyed. Option 4, that energy is heat. Well supported. That energy cannot be created or destroyed, only transformed. Which law of thermodynamics states that heat will always flow naturally from hot to cold, also called the law of entropy? Option 1, first law. Option 2, an if. Option 3, show if. Option 4, zeroth law. Spot on, an if. In thermodynamics, what is a system? Option 1, the object or group of objects we are thinking about. Option 2, materials with different temperatures. Option 3, an object in thermal equilibrium. Option 4, a cup of tea. That's accurate. The object or group of objects we are thinking about. Energy resulting from the motion of a substance's molecules. Option 1, first law of thermodynamics. Option 2, second law of thermodynamics. Option 3, internal energy. Option 4, none of above. Internal energy, well done. The zeroth law of thermodynamics deals with Option 1, heat. Option 2, thermal energy. Option 3, thermal equilibrium. Option 4, none of above. Very good, thermal equilibrium. How you will get all these quiz questions in PDF books format. Option 1, contact Narayan Changder on Facebook. Option 2, send an email to cbsanet4you@gmail.com. Option 3, none of the above. Option 4, contact Narayan Changder. Nice work, contact Narayan Changder.